So this is a very difficult question that mixes logarithms with arithmetic series. So just to quickly talk about this terminology, what this means is that you want to add up all the terms of this particular sequence from when you substitute n equals 1 into the sequence all the way up to when you substitute n equals 50 into the sequence. So you want to add up the first 50 terms of the sequence, if that makes sense. And to do that, we're going to use this formula here. So we're trying to find the sum of the first 50 terms, so we know n, the number of terms we're going to add together is 50. Same here. We're trying to find it in terms of k, so we need to write a and d. So a is the first term and d is the common difference in terms of k. So let's first find the first term. The first term is what you get when you put n equals 1 into this sequence. So let's do that. So we have k plus log base a of b to the power of 1 when you replace n with 1. So I'm just going to write a, the first term, is what you get when you put 1 into the sequence. Great. Now what we know about logarithms is that the power rule, we can bring the power forward as a coefficient. So we can rewrite this as k plus 1 log base a of b. And then now it tells you log base a of b is equal to k. So that's just equal to k plus 1k, or just k plus k. So that's equal to 2k, meaning the first term a is actually just 2k. How do we find the common difference though? That's one of the hardest parts of the question. We found that the first term is 2k. If we find the second term, we can then find the difference between the first and second term because it's an arithmetic series, and then we can say that's our common difference because the difference is the same between the first and second term as it is for like each other consecutive term. So for the second term, you replace the power n with 2. So we have k plus log base a of b to the power of 2. I'm going to write that out clearer, sorry about my handwriting. We can then once again bring the power forward as a coefficient, so this becomes k plus 2 log base a of b. And lastly, we can replace log base a of b with k again. So this becomes k plus 2k, which is equal to 3k. If we compare 2k to 3k, so if the first term of the sequence is 2k and the next is 3k, we can say that the common difference is just k. And now we can form an expression. We can say 50 over 2, which is 25, and then in brackets 2 times a, which is 2 times 2k, and then plus n minus 1, which is 50 take away 1, so that's 49, multiplied by the common difference k. Perfect. 4k plus 49k is 53k, so that's 25 multiplied by 53k, and that will just equal, I'm just going to quickly do that on my calculator, 25 times 53 is 1325k, and that's your final answer. Quite a unique question, so I thought I'd share it. But yeah, if you liked the video, please leave it a like, and if you have any questions, just let me know in the comments. Otherwise, I've linked my email in the description as well if you have any tutoring inquiries.